Let's start. That's how it should work. I believe we can start, guys. Let's begin. All right, guys. Thank you so much for coming today. Some couple announcements. We have some new changes. It was before in logo. Now we made the decision slightly change. So our community, not just Java. Why? Because we have a couple already sessions where we discuss about life in IT, how to improve management, how to find new jobs, and so on. So not only Java. And today we're going to discuss about why the world should love this. And Billy will share his knowledge. Our couple of people who are missing with us, Baruch and Evgeny, meantime Phil and Kate with us, and we're helping to support our community. Our sponsors, Rebel, who help us and help to join us, all of us, Java community, and of course Nashville Technology Council, who help us to find places where we're sitting here, with books already helping us, and of course JUG. They provide us license, and we will have a raffle after the sessions where we will try to find who will have license today. And the sponsors of the pizzas, Jam. The Jam is Jam Dev. They developed huge, in my opinion, interesting tool for bug reporting. We are have some announcements about engineering, and we strongly recommend to visit this engineering where we're going to discuss about startups and nationals. I think it's going to be interesting for us. And in Denver, October 1st, what's going to be the deal, you know?
Yeah, Death and Next, run by Bingcat, so yeah.
Absolutely. This is going to be more than 70 speakers, and including Baruch. And you?
Yeah, unfortunately not this time, but maybe next time.
And we can help you provide some discounts for that sessions. And who wants can make a photo and take it. And just thank you. All right. see what screen.
Yeah, there we go. Cool. All right, everyone. Thank you for coming out. My name is Korando, Java developer advocate at Oracle, but don't hold that against me. And okay, cool. And yeah, so thank you for coming out. Thank you to the Nashville, I guess now not just Java users group for inviting me out to host. Been looking forward to doing this. This is actually the last of a whole tour I've been doing. So I hit 4 Java user groups over the past 4 days. So I started off in Raleigh, then I went to Charlotte. Yesterday I was in Nashville, and now here I'm in Nashville. It's been a lot of driving, but it's been fun. It's been great seeing and meeting so many Java developers over these past few days. So I'm here to talk about my presentation, why developers should love testing. It's actually kind of nice. I actually gave this presentation back in Charlotte and gave it again here, but I haven't given it in a while until I gave it to Charlotte. So I'm kind of happy to get back to talking about this. This is actually kind of going back a little bit to home for me, since I kind of got my start presenting, doing on automated testing kind of back in 2017. At the time, JUG had just been released, and for whatever reason, like no one else was presenting about JUG and like in the US at the time, so I got invited to like a lot of Java user groups and a lot of conferences I might not usually got invited to, so that was really cool. So some important information. Please, at any point, ask questions. As far as my presentations go, this is very much more a philosophical one, so it's definitely much more about discussion, and so just feel free to ask questions, disagree if you want, and we can kind of talk about this. And if you want to also reach out to me, feel free to reach out to me at billy.crandall@oracle.com. I'll be happy to answer any questions you might have. And you can also get a link to this presentation at wcrandall.github.io. You can see it right up there as well. Also big news, also on the subject conferences, Java 1 is coming back. We're going to be hosting it March 17th through 20th in Redwood Shores, California. You can learn more at oracle.com/Java1. We're hoping to open up the call for papers here within the next month or 2. And if you would like to know more, so I was having some discussions earlier about people were asking like where Java is heading, or also just learning about different Java concepts. So a great resource for that is dev.java. So that we have a bunch of tutorials covering all the important concepts of Java. Also, we have a very nice community page where you can actually go and find all the different Java user groups. So if you're out just traveling and maybe you're like, I have an extra day, maybe I want to go to a Java users group, you can actually use that map to see all the different Java user groups out there, or maybe you're interested in presenting. That can also be a good way of doing that. Inside.java, also a little bit about like where Java is heading. So all the engineers that we have working on developing Java, whenever they kind of write an article, we try to actually aggregate them all on inside.java, and we also have some other articles we include there as well. And finally, we have our YouTube channel and our podcast. All right, for agenda, first we're going to cover why you should write tests. From there, then how we can write tests that you'll actually like and enjoy, followed by writing reliable integration tests, which is can be a difficult thing, though actually there's been a lot of tools that have been developed over the recent years that have made it actually a lot easier to do since I first kind of started talking on this subject, so that's very nice. And then we'll also kind of added a new section recently to this presentation about just a few additional tooling options. So, why write automated tests? Was just serious about what it means to do automated testing. It's a substantial time and effort to write tests, and it's a substantial time and effort to maintain tests. Like as you're first writing tests out, it'll be like, oh, okay, like your code isn't changing too much with it, so it's fine. Like it doesn't really cost you anything to maintain them. But over time, as you're starting to really build out a automated test suite, the effort to maintain those tests can start to become pretty substantial because your code is going to be changing, and you're going to have to update those tests as those breaks happen. Because if your code is changing, then your tests should be breaking at some point as well. And all that time you spent writing tests and all that time you spent maintaining those tests, well, that time is taken away from potentially production code. So there has to be some reason we're writing these automated tests that just doesn't rest on best practices or something we should be doing. It has to actually provide you a real actual benefit that helps us. And that it really is that the foundation of what an automated deployment process runs is an automated test suite. You're not going to be running or deploying any application automatically to production without some sort of verification of it, and that can only be done with automated testing in obviously a automated fashion, because if you're making changes and then you're releasing breaks, you know, that you're going to either potentially lose money because of, you're charging someone, a customer, the incorrect amount, you're losing reputation because the application you're releasing is very buggy, so your customer or whoever's using it is not happy with it. So it's not sustainable in the long run, so you need to have some sort of a verification process. Historically, that has been a very manual process. Before I became a DevRel, every place I've worked at, it was very much a manual process. We'd have, a bunch of QA testers that would go and test their application to make sure it was correct. But ultimately, when you kind of get to an automated process, because kind of the reality is, like, early on in my career, I was working on large, like, monolithic applications that would be, several hundred files, and, some of those files would be several thousand files long, or several thousand lines long. And so, to me, I was kind of thinking, when I was releasing this code in production, primarily the code I was releasing was code that I wrote, or, my team or organization wrote ourselves. But the reality is that the code that you actually release in production is just like the tip of the iceberg of the code that is actually being run. So, of course, have your code, but below that you may have some of the libraries you directly depend upon, like maybe you're doing some sort of like mapping service, and like you need to calculate distances between two locations, so like you bring in some sort of library there. So it's like, it's very obvious that I'm working with this library thing. Or you have like your logging dependency, log4JSON, like infamously having an issue a couple of years ago now. But it's like, it's very obvious I'm working with that. But then you have your frameworks, like whether it's like Spring Boot or Quarkus or Micronaut or Peloton or whatever it might be. You have those dependencies, and then under that, like all the dependencies it brings in. And then below that, you have like the JDK, and then below that, you would also have your operating system. So the reality is there's a lot of code that is under there that is running below your system, and then as you make changes and updates to that, that could also impact what happens to your code in production. And so like the true cost of manual tests is that there's a very high effort to do regression testing. It's because you're trying to retest all the functionality and behavior of your application. Obviously, that's going to take a long time. And at least then, in my experience, the ultimate cost is it strongly disincentivizes keeping dependencies up to date. You don't want to be like, okay, our application works. If we were to update the patch version of Spring Boot or the JDK or any of these libraries, that's going to bring in some amount of risk from that organization's perspective of we're going to break something, and we don't want to do that. And so again, in my experience, a lot of organizations became very, very, very badly out of date with the dependencies they were using. Where, this is again a few years ago, but I remember like we were working on an application where it was like a Spring Boot 1.x application, and just like the version, like Spring Boot 1 was still supported then, but the version we were on was a year plus old. So it wasn't just like, 1.2, but we're on the most recent patch version. It's like 1.2.5 and it has been updated in months or something. So that is bringing on, a very big security risk to your organization, that there's been any known security vulnerabilities within that version of the library that you're working on, then you're at risk of that being exploited by a bad actor. And of course, then there's also just a morale issue of it. You're working on these very old versions of these dependencies, and so your developers are seeing these, newer functionality that can be helpful or useful, and of course you can't take advantage of it because it's very old. And then also just compounded with that is that it's like, we really want to get on, you're maybe on like a very old like JDK 8. It's like, man, I really want to get on to JDK 21 because you can take advantage of like all these new features. But then it's like, management will be like, oh man, but it'll be so difficult. We have to do all this work and all this updating, which will be true regardless, but then there's also on top of that, all the effort around testing. And so again, that's just kind of the experience I have, is that the ultimate cost, I think, is that it makes it very difficult to keep things up to date. Whereas with an automated deployment process, if you have like you have a confidence in the automated testing suite that it's going to catch things, then you can try to be like, hey, we're just going to update, a new version of whatever dependencies we're on has been updated or been released. We'll just update it automatically, and there's nothing that is being caught, none of our tests are breaking, then we have confidence that it's not breaking anything within our code. So the additional benefits of an automated deployment process and automated testing process is that it's actually auditable. So again, going back to my personal experience, like I would often I would make some change to my application, and then I would test it locally, or I would test it in development or one of the development environments, and it'd be like, oh wow, okay, well, my thing works, like I fixed a bug or whatever it might be. But there's been more times than I would like to admit where I wasn't testing the right environment. I was actually pointing at the integration URL or a different QA URL or whatever it is. I was pointing to the wrong one, so I was testing against the wrong thing. So like, oh wait, this bug isn't there, so it's fine, or it is working the way I was expecting. So you can't audit that. You can't audit when someone says like, yeah, no, I tested it and it was working, but they were just unintentionally working in the wrong area. But when you have an automated test suite, you'd be like, oh yeah, no, here's our test run. We can see all these tests have been executed. You can actually go in and see that it didn't work. Now, maybe release something to production, you thought you had a test against it, and you can at least go review that test and say like, oh, okay, this test is out of date. Someone commented out on assertion or whatever it might be. You can actually see why that went wrong. Whereas it's not as easily possible, because you can have a checklist where your testers go through and say like, yep, I checked, I did all these different things, but there's no way to actually know for certain if they actually did. And it's not necessarily a tester being nefarious about it. They can just be, there's gonna be a lot of honest mistakes they can do. When filling out the form, they can actually hit a space bar or something, not realizing it, and that could, impact the test. There's also the repeatability, that code that is executing your test, that is the test itself, you can just rerun it. Does it fail again? If we were to execute it again, either way, you're probably going to have something to do. If it doesn't fail, you need to kind of figure out, okay, why does it fail sometimes and not other times, or if it does fail again, then obviously you have something to fix in your code. Potentially on how you write your test. You can also be ways of testing against other versions. Like, okay, this started breaking, like why is it breaking now? We can maybe try finding a way of isolating that test and running against an older version of the code to see if it actually was breaking back then, or if it's something else that's causing the break now. So that's an additional benefit that, again, isn't as easily done with manual testing, though. I guess there is some ways to do that as well. So a big thing then is how many tests should you write? Because there can be an arbitrary, like you should be having at least 50% test coverage, or you should have at least like 10 unit tests to every integration test, or you really just do integration tests, or whatever it might be. Really what matters is what gives you the confidence to push in production without some sort of manual intervention. And so manual intervention would be like, okay, before we go to production, we just have to make sure we have a QA testers go in there and check just to make sure, because you don't fully have confidence in an automated process. And a big part of that will be management buy-in. Management, because they perhaps have a long history of understanding manual testing, how that works. It's going to probably take a lot before they have confidence in automated testing to rely upon it. Of course, part of that would be you have automated testing, and then QA testers continually find nothing before you push to production, and then that could be eventually how you move it. But eventually, the thing is that whatever gets you to that confidence level that you can go to production without having some sort of QA process to test the application before going to production, that's enough to test. So I don't know what that would be. That's going to vary. It's not going to be like a universal thing. You can have some sort of simple back-end process that goes through like every year and updates the copyright on all of your websites. Okay, you're not going to necessarily need a lot of testing around that, because the the cause for concern of getting the date wrong on a website for copyright is pretty small compared to your payment processing service where you get it wrong there. That could cost you a lot of money or could cause a whole lot of issues. So there's not a universal thing, but the thing is, it's like wherever you feel confident at, that's what matters. It doesn't really matter if you're matching something you read in a blog article or something someone said at some point, saying like, oh, you need to have 80% test coverage, anything below that doesn't work. Is what matters here is to get to that level. And I updated this. Manual testing is still needed though, not manual texting. I can sort of updated this, but it's still needed. So I don't take the way that I'm saying like there's no purpose or no place for manual testing. The purpose is that it should be part of that push to production. It shouldn't be one of those required steps. But manual testing is so important because you have all of your automated tests, but of course, there's no way all your automated tests will cover all the behavior in your application. You're going to be continually changing it over time. And a developer might have forgotten to cover some sort of test case, or the old like adage of you think you make your code idiot-proof, but then the universe develops better idiot that will then still find a way to break your application. So there's still going to be a purpose for manual testing, but it's going to be happening in parallel to development. It's going to be exploratory in nature. It's like tester's going to be like, okay, like hit the back button twice and then forward twice. Like, does that take me to a weird page that then allows me to do something that really shouldn't be possible in the application? That it's going to be stuff like that. It's not going to be again checking to make sure that application generally works, but trying to effectively, actively go out and break the application to get back to the tester, to developers on how to be improved. All right, so now that maybe you're hopefully convinced on why we should write tests, how can we write tests we can love? Because again, writing tests takes a lot of time, and maintaining them takes a lot of time, so how can we at least make it a somewhat enjoyable process? And I think one of the first things, and I actually kind of learned this from actually someone who was also very much in the automated testing area, Angie Jones, and something that really stuck with me is that she says, you should always treat tests like write them just with the same care as you would write them with production code. Again, I kind of remember early on when I first started doing automated testing, it's like, oh, whatever, it's this test code, just hammer it out, it doesn't matter, because it's not production code. But then, again, that just causes over time that you have all these really poorly written automated tests, and then you're just gonna be, it makes it a difficult job maintaining them. Prioritize readability, we'll get to that a little bit more. But then of course also don't be afraid to refactor tests as needed. Maybe some of these automated tests aren't providing a lot of value, or they're just not written in such a way that they can be better written. It's like, okay, maybe these 3 tests are all pretty similar. Is there maybe a way to kind of combine a lot of it to where it's like a similar body and then I'm just passing in this different value, so that way if it needs to be changed at some point, I can just change it in one area instead of having to change it in 3 areas. Or also again, like removing tests that are maybe providing little or no value, just over time code is being changed. I'm like, okay, this behavior doesn't make any sense anymore, we can just remove this test. So again, treat it with all the same love as you would production code. So how many people are using JUG at all right now? How many are JUG 4? Or just okay, so yeah, this is again a little bit more of an older presentation, but yeah, I mean, a lot of people who are using JUnit, or at least for a while, we're still on JUnit 4. I think probably right now, many are on JUnit 5. But if you're not, definitely consider upgrading JUnit 5 just because it's a much more flexible framework than JUnit 4 was. JUnit 4 was great at the time, but JUnit 5 is definitely a lot more flexible and also allows for things like parallel test execution, which again, if you have a very large automated test suite, being able to execute a bunch of tests in parallel can definitely help in reducing the overall execution time. There's ways to do repeated tests. It's very extensible, so you can definitely write extensions for your own organization. Like, oh, okay, we need to simulate like how we're doing like our security, you know, instead of having to like add that to all of your tests, you can create like an extension for that that can simulate that behavior or other behavior as well. There's a whole lot more, so things like test ordering as well, which would be very helpful when it comes to potential integration testing, and a whole lot more. So if you're on JUnit 4, definitely see if you can upgrade to JUnit 5. You only need to be on JDK 8, which I'm hoping everyone's at least on JDK 8, right? No one's on 7 or 6? Okay, so that's good to hear. So getting to the earlier point of readability. So again, based on my own experience early on when I was doing automated testing, so the most frequent assertion that you use on automated testing is typically going to be the assert equals. And for like the longest time, I think in my head, it was like, it made sense for me, like an actual value that I'm getting back from my application would be the first thing I'm checking, and then the value I'm checking it against would be the second thing in that argument. But how JUnit 5 does it is actually reverse, that the test value is first and the actual value is second. Now, there's no correct answer to this, but that's just the way I interpreted it. And that's what they maintain. I think that's good for just backwards compatibility and consistency purposes, like even in JUnit 5. And part of the reason they didn't really change that, or they didn't try to make it better, is that it's actually just easier to kind of offload that to these assertion libraries. Fundamentally, JUnit 5, what it's looking for in if a test fails is if it gets either just a generic exception or an assertion exception thrown. And so like when an assert and when in a JUnit 5, when it fails, it throws an assertion error, and that's how JUnit knows that that test has failed. So all the assertion library does, like assert J, which I have a lot of experience with, or Handpress, which is another very popular one, does is this throws an assertion. But like I think assert J is very fluent. You'll assert that, you know, blah is equal to, or is less than, or is like. I mean, it's a very fluent way of writing it out to where it makes it plainly obvious what you're actually trying to check against. Whereas again, with JUnit 5 or just JUnits, it can be ambiguous at times. So then on to the subject of writing reliable tests, or particularly writing reliable integration tests. Probably one of the best tools that have been kind of developed here over the past 7 or 8 years. It's actually not too new anymore, but perhaps underused. Is a tool called test containers. So one of the most difficult things with writing integration tests is like, okay, you have like a database out there, and you need a test to make sure that like, okay, if I write a record to the database, you know, is it being written correctly, or am I getting data from the database? Am I reading it correctly? And my application is processing that information correctly. And so, you know, at places I've been, like you would have some sort of test database out there. But with those, you would run into the issue of like, okay, that test database could be down at the time for some reason, or the test data could go missing, or it could go out of state. So like maybe one option I know I tried was like, okay, we'll create a local version of my system of that database. But then that just comes with all the effort of maintaining that local instance and all of that, and you know, getting approval potentially because there could be licensing concerns and all that. Test containers kind of take that away, because all it does is it's like if your application can run that service can run in a container, you can just put it into a Docker container, and test containers allows for the spinning up and the tearing down of a Docker container within the life cycle of your test, or within the life cycle of a test class, depending upon your needs. But that takes away to now, because now you can actually test against like an actual, in this example, a Postgres database or whatever it might be. Because another way that people tried to get around this was using a database called H2, which was like an in-memory database. And H2 is nice, but it also only tries to simulate the behavior of Postgres. Like you can, you know, try putting stored procedures in it, but like again, it only simulates that behavior, and so you know, you can't ever be quite sure that it actually matches that behavior. So again, you can never quite get to that confidence level of, oh, the H2 test passed, and let's go to production. Whereas with test containers, again, you know, particularly if you can work with whatever these service teams are that you're wanting to do an integration test with to make it to where they can be containerized, then you can get like a very close approximation of what the actual service would be like in production and test against it. And again, because it's local, you don't have to worry about things about like that service being down at the time. You know, you can also have it to where you have some scripts to get it all set up into the right state at the time. So it is incredibly flexible when it comes to that. Again, anything that can run within a Docker container can then be used by test containers. So it's definitely a very useful tool, and like it was very useful when I first started covering this like 5 or 6 years ago. I didn't know they've added a lot to it since then as well. So a very divisive topic within automated testing is writing mocks. I think by far the best tool for this is Mockito. I know there's been other ones like PowerMock and JMock, and maybe they improved in time, but Mockito I've always found by far the easiest to use. And yes, at least in my opinion, using mocks are in fact fine, but it's really important that as long as you're validating the behavior of the code that's using the mock and you're not doing something that's actually testing against the mock itself. A really good article I linked to here. There's actually, so when I'm saying mock, it's technically referring to a bunch of different kind of concepts. There's like a thing called like a dummy. So like maybe you're writing some code, like it depends upon like a data source being available. You're not actually testing the data source at any point, but that's just a dependency for the code. So you just have it for that, or there's stuff. And there's a bunch of different types of mocks. So you can definitely, follow this link, and there's a really good article that kind of covers the different types. But the important part is you want to make sure you're not actually testing against the mock, what you're mocking the behavior. So, like I'm thinking it's like, okay, if you have code and like you're calling to some sort of service and you want to test like what happens if it throws an exception. So you just set up the mock to always throw that exception, and you're wanting to test to see how does your code respond when that exception occurs. Or another one someone brought up is like, you have your code, like, okay, like you're passing in like a user object, and maybe it's like, okay, if it's a new user, I need to generate an ID before writing it to the database. You want to make sure that the ID is correct. In your case, you would write what's called a spy in mock terms, where you can check values being passed to it to make sure it's like, okay, yep, this ID was generated correctly to whatever, whatever correct would make sense in that terminology or in that context. So it's fine, but you just want to make sure you're not like writing, if you're writing a mock to your database, and your database is supposed to have some sort of stored procedure that when it gets written, like it does to the date or whatever, you don't want to be checking that behavior to make sure your mock is doing that, because that you're not testing anything. You're testing like your own behavior that's not actually what's happening in production. So that's where a lot of people run into issues with mocks, is that you start to test what the mock is doing versus what the code interacting with the mock is doing. One other really nice thing that's a bit more practical now is performance testing. I mean, ultimately, you still probably want to be kind of doing this, comparing in production or seeing how it is in a very near production environment. But there's a tool called JFR unit. So built in within the JDK is a tool called JDK Flight Recorder, or JFR. And what it does is it has a bunch of different things that cover behavior from all the way from your application down into the JVM. You can even create your own events as well. But like a lot of it's done by timing. It's like, how long does it take from here to here for this code to execute? With like JFR unit, you can actually get in and reference those events and kind of see, it's like, okay, is our application meeting certain performance metrics, like, how long is it taking this code to execute? So that can be kind of helpful, because checking JVM behavior, that should be much more consistent across different systems and environments. So that can be pretty useful for certain types of performance testing. There's also another tool called contract-driven development. The best known implementation the best implementation I've worked on this is if you're on the Spring area, there's Spring Cloud Contract. But basically is when you do this, you write out a contract, and what this contract would look like will vary depending upon the implementation details of what tool you're using. For example, like there's like YAML or something maybe you could write in Java now, but you're saying it's like, okay, if I call this service, like if I say like I'm creating a new user, I pass in like these fields, and then I should get like some sort of response back. Like if it's a user that doesn't yet exist, like I should get back a 200 response, and the user along with like the new ID for this newly created user. If it's like already created, then I should get back some sort of error. It's like you're defining in this contract what this behavior should look like. And where this can be very helpful is that you're starting up a new project, or you're adding some sort of new features to an existing project. And so you may have like a front-end team or the client or whoever it might be that's using this service, and then the actual back-end people who are supporting this service, you know, they're not necessarily going to develop this new service at the same pace. It's not like, oh yeah, you know, I created this new endpoint today, and tomorrow like the front-end team can work on it, and you know, you can kind of just go by step. Usually it can be a case where you start off like, hey, yep, this is what we want to do, but then like the back-end person, like, oh, production issue comes up, and they're focusing on that for the next week, and they're out, and so like now the front-end people's like, well, okay, I can't do anything now until like the back-end people have it all set up, or you know, the front-end. So what's beneficial from contractor development is that you can often write code to match the behavior of the contract, and there's services to where it can be like, okay, it can read this contract and then simulate a service based upon what this contract looks like, and you include this as part of your automated process that makes sure that the backend service matches what the contract is saying, and the front end is matching what the contract is saying. You can have that confidence that you can actually develop, and then once you actually get to production, it will also match that behavior. Of course, again, you have to actually, you know, make sure that the contractor can develop. These contracts are part of the actual automated testing process, so you have that confidence that it's actually going to match once you get to production. If you don't include it part of the automated testing process, then no one's going to care, because it's like, oh, well, yeah, I wrote down this is what this service is supposed to do, but then it actually behaves a little bit differently in production, so it doesn't matter. So it has to be part of the automated process, but it can be very useful, again, for like asynchronous development. The front-end team can go ahead, and they don't have to worry about the back-end team, but the back-end team can get them all fully ready and done, and then the front-end team can support them because it's matching with the contract is doing. They don't have to worry about the back-end team like, oh, okay, we can go change it all now because the front-end team needs something different. So some additional tooling, I just kind of want to cover. So there's definitely a benefit of separating the execution of your unit test and integration test. So whether you're using Maven or, of course, Rail, they have these different plugins called Surefire and also Failsafe. So Surefire should be only typically executing unit tests, and we can maybe get philosophical as to what separates a unit test from an integration test later. But it'd be good for these unit tests to be all execute within your Surefire plugin, and then you have your integration tests execute with your failsafe. And so this provides isolation from these two types of tests. So you know, typically your unit tests are going to be typically execute much more quickly than integration tests, and they're typically also going to be much more reliable. It's much, you know, your unit tests should really like always pass every single time. And if they're not, that means there should be something wrong with the code that needs to be actually updated. Another final benefit is it also allows different class paths or dependencies to be used depending on using unit tests or integration tests. Actually, this kind of came up recently within one of the Oracle channels where someone had both unit tests and integration tests, and they're trying to run them all under Surefire, and they were running into this issue where it's like, okay, they didn't, like, the integration test needed like a different implementation versus the unit test did, and there's no guarantee in the order of the tests that are being executed. So like some of the tests, so they would just get infrequent failures, and ultimately the solution was to actually separate these out, some running in Surefire, some running in failsafe. Because also the benefit of this as well is, in you know, your Surefire, you may have like all these test dependencies being used instead, whereas in integration, you may want to have a more production-like example, or integration tests being used, or dependencies being used, because it's supposed to be a more production-like setting. So that is very helpful. There's also a thing called mutation testing. By far the best implementation and tool for using of that, at least my experience, has been what's called PI test or PIT test. And so what this does is, so like let's say you write a test and it's like, oh, this test succeeds, but there's maybe, it's a way of auditing your test to make sure that they're actually testing what you're expecting. So what mutation testing does, it goes into your code and manipulates values. So like you have like an if statement, like you have if this value equals that value. So what PIT does, it goes like it may add like a not to the front of that, and if it adds a not and then a test fails, it'll be like, okay, your tests are actually testing this thing because we went in and changed something and it failed because it's testing it. Whereas if it went in and made a change to your code and then nothing caught it, it's like, okay, it's either this code isn't being has any tests on it at all, or the tests that are running it aren't impacted by this change to it. So it can be very good for validating and giving you confidence that your automated tests are testing your code. If you went in and to change something, it's going to catch it, or it would actually be caught by your test. So that's very helpful. So this is the part actually one of the main reasons I also added this section. This is actually something that's pretty new, but now there are a bunch of options for AI generated tests. I haven't used them yet, and now because AI has become a very hype thing, like everyone is trying to do this. Like I know IntelliJ has one. There's a bunch of like new startups that have them. Like all the major vendors. If Oracle doesn't already have some, I'm sure we'll have some very soon. I haven't used them, so I'm not going to give you a recommendation on which one to use, like I have for a lot of these other examples. It could be useful. It's one of those. It's a very new area, but it takes a lot of time to write tests, and if you could maybe just have some tool that can kind of generate. You have a few new API, just automatically generates like, okay, positive test, negative test, and a few different variations of that. That can be kind of nice of offloading at least some of that initial work. So that could be very useful. You won't want to be very conscious about how you use it. You probably don't want to 100% like, oh, well, the AI tool said I had all the tests I need. That's all the tests I need. You would still need to have some sort of human intelligence going on there. Like, oh wait, there might be some other test case that I need to cover in this, or maybe the automated tests aren't actually correct for what you're needing to do. There's a lot of different areas to consider that you don't want to totally rely on, but again, it could handle some of the most basic test cases of this handling them for you without you having to take the time and effort just to write some very basic tests, but just to make sure you have that proper coverage. But yeah, that's it. So some follow-up links. It's a bit out of date now. I haven't updated in a few years, but back when I was kind of really covering automated testing, I put together like a scenario or a repository that demonstrates using things like JUnify, Makio, SearchA, and test containers. So you can check it out at that Repo link. And also for the contract-driven development, I also put together a somewhat simple example of using contract-driven development. Here's a contract. Here's how you can set up a mock service to use it, and all that. And then also a link to as well the JFR units tool. But yeah, again, if you have any questions, well, I'm not really on Twitter anymore, but you can email me at I swear I updated it since I just did this presentation not too long ago. I don't know why that's not updating, but that should be the link I start the presentation. There you go. So, anyways, that's the correct link for this presentation if you want to also check it out for later use. I'm pretty sure it's been updated correctly. I just don't know why it's not running the most recent version I hold. But yeah, any questions or disagreements?
Thank you so much.
Absolutely, thank you.
So, you talked a little bit about the contract-driven development.
Yeah.
I don't know if that's the same thing as what I had in mind. There's talk about contract testing, where you like set up the contract on both like the producer and the consumer,
Yep.
make sure they line up. And the question that we've been talking about, we're just starting as a company to like look into contract testing. Does that eliminate the need for integration testing or like, how do those two play together, in your opinion?
So, it would be, yeah, I mean, if you've written out those contracts enough, then yeah, it could completely handle the need for integrate, like that would be your integration testing. You know, there might still be certain needs for different kinds of integration testing because fundamentally, like, it can't simulate like what happens if you have a slow response or something. Like, you know, like on the front end, it's like, okay, if something takes more than 5 seconds to respond, you know, that may trigger off a certain behavior. Like, it probably really can't ever properly simulate that. So there would still be certain probably kinds of integration tests that you would probably need. But it should take up a lot of the need for integration, other types of integration. Like, it would be a lot of integration testing there. Yep.
So it reduces, you still see the need for integration tests?
Yeah, so yeah, there probably would still be some needs for integration tests, but hopefully, you know, you would be writing contracts so where that would be your primary thing. Just like, ideally that would, I mean, it would fundamentally kind of be your kind of integration test. Because at least the way I kind of like look at integration testing is like, once you're kind of having to reach out to some sort of external service, which even in this case, you know, like you would have your contract test by sending some sort of mock service call. Like, in my opinion, like I would start to consider that integration testing. So like in that way, I would kind of consider, well, that would be your integration test, but there would still probably be some sort of need for some sort of other integration test, like a test container setting up to like, okay, what happens simulating like slow or weird abnormal behavior, or really maybe from the client side, perhaps, on like how to handle that when that happens. Good. Great question. Any other questions then? Or? All right, well, again, thanks for coming out, and if you have any other questions, you know, again, feel free to email me, or come up here and ask me a question as well.
Thank you.
Thank you.
Thank you so much.
All right, yes, you have your wrap.
Yes.
So.
By the way, about unit testing, yesterday I was in one of the assessments for the one project. They losing money monthly basis more than 70,000. And one of the reasons of losing so much money and budgets because of there is no unit tests.
Yep.
One of the reasons. It was so private for me. So, guys, how many people we have? 11, right? So, I would like to count, let's say, from you, from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay? Number 1. We have 2 books and 2 licenses. What's the book you would like to choose? Duncan Marguerite, Java to Kotlin, and Java. Sure. All right. Number 6. Who is number 6? What do you like? Intelligent license or book?
The Java
Sure. And number 8, who's okay? You need to number 8.
I'm 7. You're 8. No, you're 8.
You're 8.
Okay. You're 8.
So you have a license for Java IntelliJ. What do you need to do? You need to write to Baruch in meetup message, and he will send you a license. Okay.
Okay.
And the last license, number 3. Who's number 3? Same. Just write in meetup to Baruch. Okay. Yes. and he will send you license. Thank you so much, guys.
Thank you.
So what did you think?